Okay, good afternoon. So let us continue the lesson. I want to talk a little bit more in trigonometric equation. That is another page in your book. So usually the equations that I am going to address here is a little bit higher level ones. So you are expected to know these at the level of Math 4. But essentially the lessons are the same. So I will review and complete things. So if you remember, we can solve trigonometric equations if we are able to reduce them into 3 standard forms. Yes, the first standard form that we discussed last time is the case that sine of something that you need to find is equal to k, and I told you that the formulas of these trigonometric equations are not in the formula sheet, so that's up to you to learn them. So it is good to be able to do it immediately. So do you remember what was it? We have two scenarios, yes? Either the one what is inside the box is equal to, you remember, sine inverse of k plus n times 360 degrees, and then or, so let me write or 2, do you remember what was the other scenario when you have sine? 180 minus, thank you. So it's become 180 degrees minus sine inverse of k, and then plus possibly m times 360 degrees. Yeah, it is important to mention what is n and what is m. This is what we just, I tried to convince you that this is the case, and this is all possible cases. We cannot have more than these. But I want to ask your opinion about, I changed my color. This is something a little bit new. So what do you think will happen if I have sine of something not equal to k, but equal to sine of another angle? So what I mean, one possibility is, of course, is that what is inside the box is equal to what is inside the circle, yes? That is clear. But is it the only possibility? Clearly not. For example, 0 degrees and 360 degrees are both at the same point. Even though the angles are quite different, but the signs are the same. So if I give you this and you just conclude that this box is equal to the circle, that is just only one possibility among infinitely many possibilities. So can you somehow, if you have a good understanding of what was going on there, you should be able to predict what will be here. So I want to tell me, because this is, I'm writing in blue, is something a little bit new, okay? So I want to write something for the box, and or I want to write something for the box again. So what do you think I will write here? So in principle, this is playing the role of that k. Yes? So this becomes sine inverse of sine of circle. But you don't need to write sine inverse of sine of circle. What is that? It's the circle itself, yes? So you take sine, and then you actually undo it by taking sine inverse. So I mean, that is what I'm saying. If you know this, you really don't need to memorize this again. So this is simple. Yes? So n belongs to z, and then what can I write there? It becomes 180 minus the circle plus m times 360 degrees. And then m belongs to z. Is that understandable? Yeah. So let me give one example. I have seen the reason that I am bringing up, even though technically it is the same thing, but I have seen questions in the book like this. So let me just give you an example, or two examples. Solve the following equations. So number one, for example, I would say sine of 2x minus 45 degrees is equal to sine of 3x. Yeah, let me make this 3x and that 2x. Of course, it doesn't matter that much. And by the way, I can just simply write 2x. I don't need to put a pair of brackets. Here I have to put, because I want to prioritize this over sine. But here I have to multiply x by 2 and then take the sine. If you want, you can emphasize on that, but usually in the books they don't put pair of brackets around that. Okay, so let us solve this together. I hope that you agree that this is exactly this form. Yes, because I have equality of two sines, and then I can give the roll of box to this one, and I can give the roll of circle to this one. So this means that I'm facing two scenarios. Number one, what is inside the box is equal to what is inside the circle plus n times 360 degrees. But you know that you are looking for x, so that's just normal. Just a simple math 1c equation. You just move it to the other side. Let us do it in our head. 3x, and then I move it to the other side, it becomes x. And then I have to move 45 to the other side. Then I have to move 45 to the other side, so it becomes 45 positive. And then I have plus n times 360 degrees. And then I would write n belongs to z. So that is one group of solutions. There are infinitely many, one for each choice of n, but how many points they represent on the unit circle? All these infinitely one of them. What? How many points? No, because that's 360. 360 is just one complete revolution, yes, rotation. So that's 1 point. And the point is just 45 degrees, yes. Wherever 45 is on the unit circle, every other one is also there. Okay, but this is not the whole story, because there is another one. We have to solve that one as well. So number 2, I will get what is inside the box is equal to 180. Oh, sorry, let me change my color. What is inside the box is equal to 180 minus what is inside the circle plus m times 360 degrees. But again, as before, I am looking for x. I move minus 2x to the left. Positive 2x, positive 3x is positive 5x. I move 45 to the other side. Positive 45, positive 180, 225. And then I have plus m times 360 degrees. But because I am looking for x, I have to make x alone. So I divide everything by 5. This divided by 5 is how much? 45. And then this divided by 5 is 72, yes? And then I would write m belongs to z. Do you see any flaws? So for example, of course, this is also giving me 45. 45 is also coming out from here by choosing n equal to 0. It is also coming from here, but do you think I can drop all of them and say that this is the repetition of the previous one? No, because there are other points that this consider and this will not consider. Okay, can you tell me how many points correspond to this one on the unit circle? 5. So 5 of them will be there. Of course, one of them will be in common with this one. Okay, so you can take that one out. So one of them is counting twice, both from this formula and from that formula, but it doesn't matter. Any questions? Clear? Okay. Number 2, I have seen questions in the book like this. So number 2, let me write it like that. Number 2, I put sine on one side as before. So sine of, for example, 2x plus 15 degrees And then on the right, I put cosine x, for example. Yes, this is clear that this is not the standard equation that we have here. Because the standard equation that I am talking about today is what happens if I have equality of two sines. But on the left-hand side here, I have sine. On the right-hand side, I have cosine. But I think you will know the remedy for that. What's that?
Was it that 2x plus 15 is supplementary or complementary to x?
But it is not yet, because I don't know x. But the idea is clear. The idea, I need to use the idea of complementary angles. Because I told you that sine and cosine are not independent mathematical creatures, yes. One of them is 90 degrees, one of the other one, something like that. So here you see that I have sine, I have cosine. If I can make both of them sine, then I can use this idea. And this is possible, because that's what I'm saying. In the first I think session, I told you that that's extremely important to remember this rule. So here I write this. Instead of cosine, I hope that you agree with me that one can write sine again, but it's complement. Yes? So that is the first step that you have to do. And then you can easily give the role of the box to this, and give the role of the circle to this, and then you know how to solve it. So number 1 is 2x plus 15 degrees is equal to 90 degrees minus x plus n times 360 degrees. And then what I do, I move this, it becomes 3x. I move this, it becomes 75. And then I have plus n times 360 degrees. And the last step, I divide by 3, so it becomes 25 degrees plus n times 120 degrees. And then I would write at the end that n belongs to z, so that will give me one group of solutions. But another scenario is the other one. So in number 2, I would write what is inside the box is 180. So be careful not mess up the minus signs. Minus, this is wrong if I write it like this. Yes? Yes, sometimes I have seen students make this minor mistake, but the answer will be totally different. Yes, do you see that? What is the flaw here? So I wrote that I'm using this rule. The box is this one, is 180 minus the circle, and circle is this one. So do you think this is correct? What is the problem? Plus, or, so let me just do it in in two steps. Or if you want to do it in your head, which is of course better, don't forget to make it plus, because this minus sign is not only for the first one but also for the second one as well. So what can I do now? Just let us rewrite it again. So this becomes 2x plus 15 degrees, and then I'm in my head minus 90 positive this, it becomes positive 90, and then it becomes plus x, and it becomes m times plus m times 360 degrees. Move x to the left, 2x minus x is just simply x, and move this to the right, it becomes 75 degrees, and then I have plus m times 360 degrees. And then I would say that m belongs to z. Yes? And by the way, because I told you that it's better to study efficiently and actively, so I would say that it deserves a star here. So if you want to you have some markers, I would recommend you to mark some of the questions with some particular point, so that in the future if you want to study, you can study them fast. Because usually in principle this is not one of those problems that you forget what to do. If you forget this, of course you forget everything, but still you might know a lot of things, but you forget about the point of this question. That's why I put a star there. so that in the future when you want to review for the national exam, you should be able to review the salient points quickly. By the way, I also found a set of problems written by an American author, which is very good collection of problems with detailed solutions. So I would recommend you also to look at it. If you don't understand, we can always negotiate. I will upload it to the Google Classroom. I will choose some of them today and solve it for you. Okay, so the second part of the lesson is write the blue one for the case of cosine, and then write the blue one for the case of tangent, review and complete. Okay, so now can you tell me what was the formula for cosine? So number 2, this is the review. Number 2, do you remember what we had? Cosine of the box equals to a number k. So do you remember this? So what is inside the box is equal to what? Do you remember? Plus or minus of what? Yes? Inverse of what? Of no, cosine inverse of what? K, yes, plus n times 360 degrees. And n belongs to z. Yes, thank you. Of course, I told you that if you don't like negative angle, you can also work with 360 minus that angle. But this is more common. But then immediately you can write a blue version of it. If cosines are equal, then what you can conclude? The box is equal to plus or minus the circle plus n times 360 degrees. And then let me just immediately write number 3. So number 3 was the case of tangent. Do you remember what was it? What is inside the box is equal to what? So we can consider these two as one package, and then this and the less those ones. So what can I write in front of this? Tangent inverse is clear. Yes, and then yes, so that was the crucial point. If you insist to keep 360 here, then you had to write 2 formulas. But we learned that for the case of tangent, we can always combine them into one single formula. For case of sine and cosine, sometimes it is possible, sometimes it is not possible. So I have to write it in 2 forms. But in this case, it's always possible and it's better. And then immediately you can also guess what happens if I have equality of 2 tangents going on. Yes, so what can I conclude here? I can conclude what is inside the box is equal to this inside the circle plus n times n times 180 degrees. N belongs to z. I also forgot to write here, so n belongs to z. Okay, so now my goal is to give you more examples. That's the lesson is more or less completely finished. But you need more experience about how to use them efficiently. There might be different questions. One question I found interesting in the book, it is a very simple question, but this is one of those questions that I think deserve to have a star. I don't know exactly the numbers in the book, but I just give you the essence. So, example. So from now on, I just want to solve examples. There are no lessons, okay? Solve the following equations. And I would say that instead of putting a star one by one, I would put all of them is important. So number 1, this is the one that I told you I want to choose more or less from the book, but I changed the number so that I can have it in my memory. So I would say sine x is equal to, so let me make it a little bit different from the book. So sine of 2x is equal to the second root of 3, square root of 3, times cosine of 2x. So you might think that you know the solution based on the experience you got from number 2 up there. But do you feel the difference now? On the left I have sine, on the right I have cosine. You might think that you can use the same trick to solve the problem because one is sine, one of it is cosine. I can use the complementary technique again. But the complementary technique again, of course, solves this part. Instead of that, I can write sine of 90 minus 2x. That's correct. But it is useless again. First of all, tell me why this is useless if I do that. Do you understand what I mean? So I mean that in that experience, you see, do you remember here it was sine on the left, cosine on the right. And then we just use this trick by writing sine of complement. Here I can do that. It is not wrong. So I will get sine 2x equals to square root of 3. Instead of cosine, I can write again sine 90 minus 2x. But in this case, it is not helpful. Why? Why it is not helpful? Yes? Yeah, it's not standard because unfortunately I have a square root of 3. This only works that if this coefficient and this coefficient are both equal to 1, which in this case is not working. So that's what I'm saying. Even though this was tempting to do this because of that experience, but apparently it doesn't work. Do you want to suggest to do something? Yes? Yes, by dividing everything by cosine 2x. Yes? So this is why I'm saying this is not you see the standard ones you need to know, but then you need to practice a little bit to understand how we have to proceed. So this is one of those things that you have to put in your toolbox. You have some archetype examples. So here we have to be patient to see why it works. That's the only thing that I can tell you, right? So I divide everything by cosine 2x. So you need to be patient and see why it works and then learn. If you get this, do this. So sine 2x, and then you divide cosine 2x. So let me be patient and write everything. So a square root of 3 cosine 2x, and then I divide by cosine 2x. Hopefully at this stage you really shouldn't have this problem. If you have to review things. So what can I write instead of this guy? What? Yes? Yes. So I have sine and cosine of the same angle. If I divide them, it becomes tan of the same angle. So that's clear. It becomes tangent of 2x. On the right hand side, what will happen? This cosine and cosine are totally cancelled. I will get square root of 3. Now you are patient and you actually saw that this is working because this is a standard problem. Why? Because this is of this black type here. Yes? But I have to be careful when I want to divide by something. Yes? I can only divide if I am certain that that number is not 0. Yes? But do I know for sure that this number is not 0? At this stage, at this moment, no. Because I don't know x, so I don't know cosine of 2x. If I am so unlucky, it might happen that this becomes 0. But I want you to tell me why I can guarantee that cosine 2x is not 0. And then this is legitimate. Why do you think cosine 2x in this particular case is not 0? Yes?
That cosine 2x is not 0 or x is not 0?
No, cosine 2x is not 0. I don't care about if x is 0. By the way, if x is 0, I don't have any problems. Why? Because if x is 0, 2 times 0 is 0. Cosine of 0 is 1. So I don't have any problems. What matters is that cosine 2x, which is going in the denominator, shouldn't vanish. But I am telling you, even though still I don't know x, if I knew x, I don't even bother to solve it. I know x. The reason that I'm solving it is because I don't know x. But I am telling you, even though I don't know x yet, but I am certain cosine 2x cannot be 0. Why is that? No, no. So how do you know that? Because this is the equation that I gave you. How do you know that cosine 2x cannot be 0? No, the one below this is not the original one. Because when I want to go from this step to this step, at this step I have to convince myself that cosine 2x is not 0. Otherwise I'm not allowed to go further. So before dividing, I have to make sure that cosine 2x is not 0. Cosine 2x is not 0. Let us see what is the consequence of the assumption otherwise. If cosine 2x is 0, if cosine 2x is 0, then okay, I expect you to be able to tell me what is sine 2x then. If cosine 2x is 0, sine 2x has to be equal to, yes? No. Sine 2x. I'm not talking about the angle. I'm talking about the sine 2x. Yes, Kamil? 1 or minus 1. Why is that? Can anyone say? Yes?
Because x would have to be 45 degrees and sine of 90 degrees as well.
But I told you just 1 and minus 1. So how did you come minus 1 then? Yes. Yes, that is one way of understanding. Another way that I want you to understand is to be able to use this formula effectively. Yes? This formula is always valid, regardless of my choice for x. This is the most fundamental identity in trigonometry. Yes? If you tell me cosine 2x is 0, this part will go away. And then sine to the power of 2 is equal to 1. So there are two options available for sine. Either 1 or minus 1. But if cosine is 0, according to this equation, sine 2x should also be sine. If cosine is 0, when I put it here, multiplied by square root of 3, sine 2x also becomes 0. But simultaneously this is impossible. Because if sine 2x and cosine 2x are simultaneously 0, then the left hand side of this identity is 0, the right hand side is 1, which is an evident contradiction. Yes? Is that clear? So, I mean, even the book doesn't bother to discuss this, but this is essential. So you cannot divide, okay? Or you can do something. You can divide, and then when you got the answer, check for if this is a fake answer or not, a false root or not. Okay, but I guarantee you that there will be no false root because cosine 2x is not 0. Is that understandable? So what I'm saying, if cosine 2x is 0, from this equation sine 2x is also 0. On the other hand, I know this is always true. Okay, so this means 0 plus 0 should be equal to 1, which is a contradiction. So this cannot happen. Anyway, any questions here? Yes? No, if you don't by this argument you understand that there is no false root. But if you don't care about this, and then you have to, when you found the answer, you have to take it back and put it into the original equation to see if it really works. No. In general, I would say no. Because it depends on the type of questions. For example, in root equations, it was not evident at all. We have to go back and check. Okay, so now anyway, I think now this is I would consider this, if you didn't know about this, might be this an A-level question or something, or C-level question, but now we reduce the level to the one previous one. So if this is C-level, I will consider this E-level, because this is the standard. Why? Which one is that? Is the formula on the board. It's a standard one. The only thing that you need to do is to take this as your box. And then what is inside the box means 2x is tangent inverse of that number. And then plus n times 180. But you need to know that this number is famous. That is enough. Because if you know this is famous, then you can go and look it up in the table. And then if you do that, what is this angle? Tangent inverse of square root of 3 is 60 degrees. Yes? So then becomes 60 degrees. So 2x becomes 60 degrees plus n times 180. And then I divide everything by 2. So this becomes 30 degrees plus n times 90 degrees. And then what happens? N, sorry, I have to write n belongs to c. So that is the answer to this problem. How many points do you think they will represent on the unit circle? 4, yes? Because 90 is a quarter of 360 degrees. So you go 90 degrees each time. You start with 30, for example, and then 90 degrees, 90 degrees, 90, so you will return back. So 4 points, yes? Okay. So this is one of the questions. And now let me take some questions from this American author. Yes. Or so okay. Number 2. By the way, these are exactly at the level of Math 4. So these are not high-level questions. But of course, I would consider them A-level questions. So cosine x sine x is equal to cosine x. Okay, this is a good example. This was a coincidence, but this is a good example to understand what I described here about this discussion before. So can you tell me how can I solve the problem here? By the way, let us review everything. This is a trigonometric equation. Why? Because you see equality and your unknown, whatever it is in front of sine or cosine. And you're supposed to find the value for x. So that's a trigonometric equation. How can I solve a trigonometric equation? There's only one way for me to do it, to be able to reduce the equation into one or more of these standard ones. That's the only thing. So this is not by itself a standard one. So I have to reduce it to a standard or one standard or two standard forms. So then there is no way that I can teach you unless I give you a lot of examples that I increase your experience. So what should I do here? Yes? Okay, so that's a good example. So you want to divide, okay? So then what happens, by the way? You get sine x equals to 1, and then sine x equals to 1 is a standard equation, and you solve it. Okay? But I just told you, when you divide, you have to be careful that is what you are dividing is not 0. But you didn't care again. And after 15 minutes, yes? So care about what when I emphasize something, this is coming from a little bit, I don't know, 30 years of experience of teaching. So when I emphasize, it is really important. Okay, so if you divide, you are assuming cosine x is not 0. Otherwise, you're not allowed to divide. But how do I know? Can cosine be 0 in this case? Indeed, yes. Because if cosine is 0, the left-hand side becomes 0, the right-hand side is also 0, 0 is equal to 0. So if you just divide cosine x, you are throwing some possibility out of the problem. Do you understand what I mean? So here you are not allowed to divide. Because this is your bad day. This could be 0. In this case, if you just divide and didn't care, nothing strange will happen. Because cosine couldn't be 0, and you were lucky. But here, you're not that lucky. Yes? Because if you divide, you are just throwing one possibility away. So it doesn't mean that what you get is wrong. What you get is not the whole story. Yes? So you're losing one part of the solutions. Okay, so can you tell me then what to do? Either you can divide, but remember cosine x equals to 0 is one story, one part of the story. You have to consider it. But I prefer you to solve it in this way. If I want to solve it, I move this to the left. And then tell me the rest. You tell me the rest. Yes? Okay, what will I do now? What? Factor. Yes? And then when I factor cosine x out, what rule I am going to use? I don't know, even this name is common, but I have used it for you a lot of times. So this is a product of two numbers. One number is cosine, The other one is this combination sine x minus 1. And the product happens to be 0. So this means, what can I conclude from here? So if you don't mind, let me write here. What can I conclude? Either cosine is 0 or sine x is equal to 1. And now you see that in this way of solving, you automatically consider the case cosine x equals to 0. So I would consider this is a good way of solving the problem. Yes. But now I have two problems to take care of. So if you don't mind, let me call it A, and let me call this one B. Okay, for A, cosine x is equal to 0. So then I can use one of these formulas here. It's a standard one, yes? So this means x is equal to cosine inverse of 0. Can you imagine it without referring to the table? Cosine of which angle is 0? One of the famous angles, yes? 90, yes? So I would say 90, but I have a plus or minus. So this becomes plus or minus 90 degrees. Yes? If you want, might be you read it in the future. So let me write everything. Cosine inverse of 0. But do you remember I have to put a plus and minus there? And then plus n times 360 degrees. But this is 90, so x becomes plus or minus 90 degrees plus n times 360 degrees. N belongs to z. This is one part. Now part B, sine x is equal to 1. So what can I say? Again, I have two options now. Either x is sine inverse of 1, yes, plus, I don't know, I can call p m times 360 degrees, or x is equal to 180 degrees minus sine inverse of 1 plus, I'd say p times 360 degrees, yes? M belongs to z, p belongs to z. But let me simplify them. So can you imagine, without referring to table or calculator, what is sine inverse of 1? It is asking you the angle of, the sine of which angle is 1? Yes? No. 0. Sine is the y coordinate. Cosine is the x coordinate. So it is not. It is 90. Do you agree? It's 90 degrees again. By the way, very interesting things happening. I couldn't foresee this myself. So what happens here? This is 90. So this means that x is 90 degrees plus m times 360 degrees, or 180 minus this one. This one I could see, but another thing I am telling you I couldn't see. Okay. So I got this, or that. If I ask you how many groups of solutions I got, no, I just 2. Yes, because these two doesn't have any differences. Do you agree with me? I didn't know what will going to happen, so I chose M and P. But actually they are referring to the same angles. Do you agree? Because it starts with 90 and I go full rounds around. Yes? And this is also the same thing. So this and that are not different. Okay? So when I consider this, I don't need to consider that. But I don't need to consider this one as well, because I considered this before. So that's exactly interesting. If you just drop this one, you are dropping the essential part, because the answers are those things. So at the end, if I ask you, how should I write the answer? So let me write this in this case. It's a little bit. So if I ask you to write the answer, I just write this. Understandable? Yes? Okay, good. You know, the problems are not hard, but they are very sometimes lengthy, and detailed. So you have to be careful about your calculations. But if you understand and do them patiently, I wouldn't call them very hard. So let us go to the other two problems that are also important. So let me keep the formulas. So let me start writing here. Another question that I want to solve, again I will choose from this. Okay, 2, so this is number 3. So 2 cosine x squared minus 5 cosine x equals to 3. Okay. So all these examples are important. I mean, for the national exam, so you might get some question at these levels. It's completely common. So I want to hear from you first. What is your opinion? I am solving a trigonometric equation. Why? Because I have equality. I have x in front of cosine, for example, and then I am looking for finding suitable angles for x. The only problem is that unfortunately it is not a standard form. Yes?
Is it possible to use the ABC formula?
Yes, thank you very much. So that is exactly quadratic equation. So that is what we called auxiliary variable, if you remember. So I would say that let x be equal to cosine of little x. Yes? Auxiliary is the spelling of auxiliary correct? That is a different story. You can tell me. Yes, what is? Okay, I hope so. Yeah, I mean auxiliary is something like, so we have here AUX mic or something. Yes, AUX means auxiliary. Yes. Pardon? Okay. It's correct. Okay. Thank you. Okay, and then what happens? Then it becomes 2. This is this 1 to power 2, so it becomes this. And then it becomes minus 5x. And on the right hand side I will have 3. But then everyone knows that this is just a quadratic equation, and preferably I use ABC formula, because otherwise I have to divide by 2 and work with fractions. So what I do, I move this to the other side. So this means that 2x squared minus 5x minus 3 is equal to 0. And then I use ABC formula. So the capital X is equal to, do you remember the formula? If you want, I can write it here. Minus b plus or minus divided by 2a. So then it becomes a 5 plus or minus square root of b squared is 25 minus 4 times 2 is 8. 8 times minus 3 is minus 24. So minus minus 24 becomes positive 24. And then divided by 2 times a is 2, so it becomes 4. But that is good, because this is a lovely number. So 25 plus 24 is 49. 49 is 7. So it becomes 5 plus or minus 7 divided by 4. Then I will get 2 answers. X is equal to 5 plus 7 divided by 2 is how much? 3. And then 5 minus 7. Am I right? It seems right, yes. 5 minus 7 minus 2 divided by is how much? Minus a half. Let me double check my answers. Do you agree with me? 5 plus or minus 25. Yes. 7. Yeah, that's correct. Yes? Okay, but now my goal was not to find this auxiliary variable. I want to find my original variable, but I use it. Yes? This is a little bit unfair. You bring something in, use it, and throw it away. Yes? Usually it is not good to do this in life. Yes? This poor auxiliary variable is actually doing everything for us, and then we throw this away. Anyway, life is not fair, is it? So x is equal to 3. Then what we can conclude? We can conclude that cosine little x is 3. Okay, now can I use this? Is it a standard one or not? Yes or no?
Yes.
So the formula is this one. I can use that, but of course 3 is not a famous one, so I write plus or minus cosine inverse 3 plus that. Yes? Agree or not? Yes or no? I'm just asking you because I think that you're sleeping or somehow. So yes? So k is 3, and then I would write this plus or minus cosine inverse of 3 plus n times 360 degrees. Yes? Yes or no?
Final answer.
Why no? You want to say? Alina? Why not? Yes? Yes?
It's not allowed to be greater.
1. So you just say no solutions. Yes? So don't use the formulas blindly. So no solutions. Since 3 is greater than 1. But we know cosine is maximally 1, minimally minus 1. So yes, but another scenario we have, what is that one? X is equal to minus a half. So this means that cosine x is equal to minus a half. Okay, again, ask you, can I do this formula now? Can I use this formula now? Yes, because minus 1/2 is really between minus 1 and 1. But then you need to remember something. This I don't know how to tell you, but so x becomes plus or minus cosine inverse of minus a half, and then plus, let me also teach you here, yes, 360 degrees. This is completely correct, but to be honest, if you can calculate this, it is better to do it. Yes, unless it is not, unless you don't know it exactly. Can you test it in your calculator? If you do that, it should give you 120 degrees. Yes? But the point is that what happens if you are in that part of the exam in which the calculator is not allowed? And definitely you will not have negative numbers in your table. If you have seen that table, by the way, I can upload the formula sheet so that you can see the formula sheet that you will getting, but there are no negative numbers in that table. And then I told you that calculator is not allowed. This is that part of the exam. The only thing that you have available is the formula sheet. Okay, then what? If you write this, there are some points that you will lose. Yes?
On unicircle, that's the other circle point. You can make that 0 point in where you can have the values.
So that's exactly the case. Yes? So, but you need to be suspicious about that. So remember, 1/2 is a famous number. You will find it in table. But what is 1/2? If you look at the table, 1/2 corresponds to 60 degrees. Okay? But then you want to have something to be negative 1/2. Yes, that is easy. Because when you say that in that table, you will not see this number. But in that table, you will see the positive 1/2 one, which corresponds to 60. This you can read from that. But now you understand you want minus a half. So it means that you need to go to the mirror image here, and then you realize that this angle is 120. So that's the way that you have to do it if you want to get it complete. So this one plus or minus 120 degrees plus n times 360 degrees. N belongs to z. And then this is the final answer to this part. So this one, let me also put, so for the future reference, important to understand, yes? Important to understand this step without calculator. Pardon? Yes, I mean, I told you that this answer that you have got gets the most of the marks, points, but if you're supposed to give me the exact value, and if it is not allowed to use the calculator, so you need to know how to find 120 yourself. So unit circle gives me for 1/2. So from the table I see that for 60 I have 1/2. But it is cosine, so it is related to the x coordinate, and I want to have it minus 1/2, so it becomes the mirror image of that one. So that angle will be 120 degrees. Yes?
So in the answer, are we not simply allowed to write cosine inverse? So we need to actually write the exact value or something?
It depends on the question. For example, if this angle, if this number is minus 1/3, if I ask you to keep it exact, you just write cosine inverse of minus 1/3. But sometimes people ask, write it up to 2 decimal points, then you have to put it in the calculator. But what I'm telling is that assume that this is given in that part that you are not allowed to use the calculator, and it has mentioned to answer exactly. Then this is the way that you have to do it. So you have to visualize, otherwise you will not be able to do it. Any questions? Yes? Okay, so let me give you another one. So this was number 3, so I go to number 4 here. So if you don't mind, let me keep the formulas in front of us. So so I go here. I will also choose another problem from here. So let me, what was that? Number 4. I want to choose the one which is slightly different. 7 sine x plus 5 is equal to 2 cosine x squared. Okay, so there are some similarities between this problem and the other problem, but there is something unfortunate here going on. In the other case it was a pure problem, it was just cosine, but here I have a mixture of sine and cosine. I want to hear from you what to do. Yes?
I don't remember if it was a concept of your complementary, but when you like switch sine to cosine, like how we did before with
Okay, do you think it will work? In this case, if I change sine to cosine, I have to write cosine of 90 minus x. That is totally true, but it is not helpful. Do you agree? Because then I cannot use this trick of auxiliary variable, because then I will have cosine x on the one hand and cosine of 90 minus x on the other hand. Which one should I take as the auxiliary variable? Yes, so remember, these tricks you need to put in your toolbox. So whenever you want to interchange between sine and cosine, that was one trick, to use the complementary angle. But there is also another trick. Put it in your toolbox. Improve your memory, okay? So what is that? Do you want to answer? Yes?
if you
x to the power of 2 to 1 minus.
Exactly. So that's what I'm saying. So remember this. I don't know if you want to take notes or whatever. That's up to you. If you want to change sine to cosine or cosine to sine, there are two ways. One is to use the complementary angle idea, and the other one is using the fundamental formula in trigonometry, which is sine to the power of 2 plus cosine to the power of 2 is equal to 1 for any choice of theta. So this formula, even though written in this form, you can interpret it in two more different ways. One is to keep sine squared here and move this to the other side. Yes, or you keep cosine squared here and move sine to the other side. Yes, this will help you to eliminate sine squared in favor of cosine squared. This will help you to eliminate cosine squared in favor of sine squared. And these formulas are useful if you don't have to take square roots. Yes, I mean, here, which one is preferable? Change sine to cosine using one of these formulas, or change cosine to sine using one of these formulas? Which one is preferable here? The one that Robert mentioned is preferable, but why is that? You don't need to do trial and error, yes? Why is that?
Because then you can move it over to the other side and use the other side.
So what I'm saying is that if I want to write this, you know sine squared is what? 1 minus cosine, yes? So far so good. But what you have here, if you insist to eliminate this is not working, so you have to take a square root. And then plus and minus. So you are making life hard for yourself. First of all, you have to consider two scenarios, one positive and negative, and the other one, you have to live with solving a root trigonometric equation. Yes? So this is not an efficient way of elimination here. So this is why I will also go with what Robert said. But if you manage somehow to solve these two hard problems, combine them together, you will get the final answer. Yes? So what I'm saying is that, so remember these two tricks. To change sine, cosine, cosine to sine, either I use the idea of complementary angles. That is useful if I do not have powers of 2. But if I have some powers of 2 involved, this is a good choice to remember about it. Okay, so what I can do here, I would first, as Robert mentioned, so I would just write this and that, and then I put 2, but instead of cosine squared x, what can I write? I can write 1 minus sine squared x. Why this is useful? Because now I can use the idea of an auxiliary variable. Okay, you see sine x and sine x are appearing. They are the same thing. So I would say let capital X be equal to what? Sine x. And then what happens here? It becomes 7x plus 5 is equal to 2, 1 minus x squared. And then I have to solve this problem, yes? Okay, if you don't mind, let me just multiply, and I know it's quadratic, I move everything to the left. So minus 2x squared, I move it to the left, it becomes positive 2x squared. I have 7x here, I just keep it there. And I multiply this 2, and I move it to the left. 5 minus 2 is 3. It's equal to 0. And then I have to solve this problem. So what can I do now? I use ABC formula once more. Okay, so I will solve this one. So I would say capital X is equal to minus b, which is minus 7 in this case, plus or minus a square root of 7 to power 2, 49, minus 4 times a times b is 24. And then I divide it by 2 times a, which is 4. This becomes 25, 5. And I get two answers. So this means that x is equal to minus 3, or x is equal to how much? Minus a half. Okay, but if x is equal to minus 3, this means that sine of little x is minus 3. What do you write in front? Less than minus 1, it's not acceptable. So no solutions. So remember, this limitation is only for sine and cosine. If it was just tangent, you could solve it. But of course, this is not one of those famous angles. You just write tangent inverse of minus 3. But anyway, no solutions. Since minus 3 is less than 1. Okay, and then x equals to minus a half. Let us practice that idea that I wrote is important. I just cleaned that, but you just try to repeat it again. So this means that sine x is equal to negative 1 half. So there are two options. So therefore, one possibility is to write what? X is equal to sine inverse of minus a half plus n times 360 degrees, or number 2, x is 180 minus sine inverse of minus a half plus n times 360 degrees. Again, the same story. Assume that this is in that part of the exam that you are supposed to give the exact answer without having access to calculator. Yes?
Wouldn't you write minus 3 is less than
Less than minus 1, thank you. Okay, so can you tell me, so you look it up in the table. Definitely you will not find this number, but you know that 1 half is in your table. And I will help you. If you look at the table for sine, you will get 30 degrees. So sine of 30 degrees according to the table in front of you is 1 half. Now can you tell me what is the exact value of sine inverse of minus 1 half? 100? No. Because by the way, 150 is in which quadrant? In the second. And in the one, and sine is related to the y coordinate. In the second quadrant, y coordinate is still positive. So there's no way that you get minus a half. So where is it? So let me just check. So 1 half, I told you. For 1 half, by the way, this is sine. So which coordinate is involved? Y. So y value is 1 half. You see it in your table, which is 30.
Yes.
But you want to make the y coordinate minus a half. So where do you go? You go here. And then you will get this angle. Which angle is that? Minus 30, yes. Yes? So you get minus 30. So the answer to this case, let me just continue. It's minus 30 degrees. Plus n times 360 degrees. N belongs to z. So that is one possibility. And the other one is 180 minus 30, which is 210. Yes? Any questions? Yes?
Why did you decide the second one was better?
Better? What do you mean?
Correct.
No, both of them are correct.
Okay, because you didn't put the box around the first answer.
No, I also put them. I was a little bit lazy, so I should say then x is equal. So that is my box. Yes. So in principle, you need to continue to box and contain x as well. Yes. Now both of them are acceptable.
You can't combine them in any.
No, no. Usually you can combine if these angles that appear here are those 4 points.
Yeah.
Sometimes, yeah, most of the time, if this is 0, 90, 270, 180, then probably you can combine them. If one of them is related to this and the other one is related to this, it is clearly they are different points. Yes, they are not related with. They are not related with. Yeah, they are not related with actually 360 degrees or something. So this is not possible. Okay, any questions? Okay, so I think this is a very good file, and the good point is that there are detailed solutions also there. By the way, if you don't mind, let us try to understand how GeoGebra will solve the problem. So let us see how it works in GeoGebra. So if you don't mind just a moment. Okay, so I go to GeoGebra, I go to, as usual, CAS view. I think all the things that can be done here. I don't know why it's not working. Okay, it works. Now I also get rid of this view, which I don't need. Might be that's also good to have it, but yeah, let us get rid of it first. I think so it is extremely important to practice whatever you learn using GeoGebra. So I will go to solve, because what I want to do is solve an equation, and then you get some. So let me see if I'm yes, I'm recording the proper. Okay, so here I go here, solve equation in X. So I think that's enough. I choose this, and then I type my equation. Let us see if GeoGebra is capable of solving that one. So I would say, by the way, we realize, I don't know if it was your class or other class, so sometimes, so in GeoGebra, according to the manual, you have to put the dot as the product. And then when you want to find, because sometimes it messes up things. So yeah, if you write 7, I would prefer to put this shift 8, which automatically gives you the product symbol here. And then I think for numbers it is not important, but if you write xy, GeoGebra consider xy as one unified variable whose name is xy. It doesn't interpret it as x times y. Yes, that's a little bit annoying. Yeah. It's not very unusual, because even the Matematica is probably the most advanced software. That's also the same. But in Matematica, you can, instead of multiplication, you can just put a space. Might be you can also do here. I don't know. But anyway, let us not take the risk. And then cosine. So you see, I want cosine. And then I choose this cosine, but that angle is gray. I have to mention that. Oh, it is, yes. Which one I am typing? No, that should be sine. So that's my mistake, sorry. So I go back. So I write sine. And then this one and that is x. And then I go plus 5. And then equal to 2. For this one, let me just type it. But I think I should type it like this, with a parenthesis here. And then I would say this one and that one and x. And then come out of this and then to power 2. So this means cosine to the power of 2x. And then I ask GeoGebra to solve it. Let us see if it can do it for us. So GeoGebra provides these two answers. The reason is that the default mode in GeoGebra is radians. And I just tell you that. Be careful, I will teach you later. But pi radians is equal to 180 degrees. That's a matter of confusion. People think that pi is 180. No, pi is the famous number 3.14 something. So pi is always pi. Yes, but pi radian is equivalent to 180 degrees. So that's different. So here, if I want to interpret this, what do I get? and then you see that GeoGebra, it's a bit probably more efficient way. Instead of m, n, and letters, they have k sub 1, k sub 2. They are actually coming from the set of integers. So here, this one, 2 times pi, how much is that in degrees? Pi is 180 degrees equivalent, so 2 pi is 360 degrees. So this is nothing except 200, it is what? 360 degrees, yes, times k1. And then can you tell me what is minus 6 minus 1 over 6 pi? Pi is 180, and then you divide over 6, which becomes negative 30. And that is negative 30 we got there. Yes, do you remember? Negative 30. And then the other one is also 360 degrees multiplied by another number. But how much is 5 over 6 times pi? Pi is equivalent to 180. You divide it by 6, it becomes 30. You multiply it by 5, it becomes 150. Yes? Yes? So, do you think I made a mistake there? It's good that we checked that. So, okay, yes, it's minus. I didn't realize. Minus 150 is exactly the same point on the unit circle as 210. Yes? So let me switch the view so that I'm explaining this. So you see here, if I go here, so that's correct. That's what I'm saying. In the faucet, you might get that answer, but this answer is also correct, because what matters at the end, you should consider, so 210, where is 210? I start from here up to here is 180. I go 30 degrees more. This becomes 210 if I go in that direction. But I can reach to the same point if I use this direction. In that case, how much I should rotate? 150. But because it is in the negative direction, it becomes minus 150. So what GeoGebra is actually providing us is actually matching with what I got. So now you realize that sometimes it is confusing, especially in the book. You solve the problem, you go to the faucet, you see the difference, but you need to evaluate. Thank you, Aaron. Okay, so yeah, that's correct. Anyway, so actually good software, but I don't know if I add graphic view, do I get something? No.
Maybe you can change it in the settings.
What? I was thinking, I understand this doesn't make sense, yes, because for GeoGebra, there is nothing to graph here, yes. So if you want, probably you can do graphings here as well, but then I have to switch that. So from graphical point of view, what can I do? For example, let me see if possible to do this, and then copy pasting things like that are very unusual in GeoGebra, aren't they? Let me see if I can hide. Yes, it can be highlighted, but it doesn't work. Okay, Control C, and then let me go here back again. Equals to V. Control V. Yes. No, it doesn't draw the graph. So why this is here then? I don't know.
You might have to switch the interface to a different. Sometimes I feel like it would be default.
Yeah. So I mean, I know if I go to algebra, it probably will work. Yes. Not algebra, no. I have to go to graphics 2D. Anyway, so it has decided not to work today. And that's clear because this is Friday and we have to go to have a weekend, yes? So have a nice weekend, thank you. Yes. But please try to work things with GeoGebra. Yeah. No questions? Thanks. I will upload the PDF file of the American writer.